Good day, Doctor. Today we would like to present our EMT project with the topic Electromagnetic Induction of Wireless Charging. I am Ting Xing Yi, AE230061.
And my name is Chakika, AE230058.
My name is Eddie Cheng, AE230053.
My name is Jopali, AE230073.
My friend will present the introduction part.
Okay, so first of all, what is the means and what is the wireless charging? So wireless charging is a innovations and increase the common technology that enable electro device to be charged without physical connections or direct electrical contact. So these advancements enhance convenience, reduce wear and tear on the charging ports. So in our projects, we use the fundamental principles of behind wireless charges is electromagnetic inductions. That's a phenomena first discovered by the Michael Faraday in 1830s. So Faraday's law is about the electromagnetic inductions is a law of the electromagnetic predict how a magnetic field will interact with a electric circuit to produce a electromotive force EMF lah. So it show a charge of the magnetic flux links with a electric circuit give rise to the EMF in the circuit. So that's is my intro part. Next will be the objective.
So for the objective part, in this project, we used to develop a wireless charging system capable for efficiently transferring the electrical power from a source to a mobile device without the need of physical connectors or cables. It is reliably charged device using the inductive power transfer, and it will achieve the sufficient power transfer efficiency for practical use. And it also simplifies the user experience by removing the cables. And it also addresses the safety and compatibility concern with the widespread adoption. So for the next part is the scope of work. In this project, we do the analyze for the problem and do the research on principles and material use, and we design and build a simple prototype of DIY wireless charging system. And we also test the prototype to see how well it works and not any issues or limitation. So we also compare the result with the expected outcome and suggestion the improvement if needed. So for the next part, we'll present by my friends.
So the next part is the methodology of this project. Firstly, the transmitter coil is a winding of 15 turns of copper wire, and it is coiled around a circular form. Next, the transmitter coil is connected to a simple oscillator circuit that includes an NPN transistor, PIP41C, resistor, and the power supply DC supply as to generate an alternating magnetic field when it is powered. The function of transistor is a switch that rapidly turns off the current or turn on the current. This alternate current generated through the transmitter coil. The alternating current also creates a time-varying magnetic field around the coil, and it is essential for electromagnetic induction as in figure 1. Next, the receiver coil can also be wind up to 30 turns. This number is important as it helps optimize the magnetic coupling and the voltage induction between coils. To make it smooth and regulate the voltage in the receiver coil, a 7805 voltage regulator is integrated IC is used. The 7805 IC is widely available linear voltage regulator that met an output constant of 5 volts, which is the standard charging voltage for any smartphones nowadays. In addition of components like diode, 1N4001 and capacitor, it helps to stabilize the circuit and Zener diode to protect it. The receiver coil output is connected to the phone charging port or battery input, and finally, the coils are positioned together and the setup is as shown in figure 2. Next is the scope of the work.
So in the expected results, we have two coils. First is the transfer coil and the second is the receiver coil. So the transfer coil, we have the 15 turns connect with the NPN transistor, and the power supply, that is our USB connector. And the second coil is the receiving coil. They have 30 turns, connect with the 1000 microfarad capacitor and the diode, and the voltage regulations, that is 7805. The function of the 7805 IC is to prevent the output voltage is 5 watt. So two coin put closer, then we can connect the Type-C connector to our phone. So the functions of charging is good. That's all.
So for the hardware, later I will show you in a video.
Kita guna itu TIPC 41C. So ini adalah NPN transistor. Lepas tu ini ada kapasitor. Lepas tu resistor. So kita guna 30 turn untuk copper coil. Sini pun 30 turn. So kita guna voltage regulation. Kod dia 7805 dengan 1000 microfarad kapasitor. And kita buat itu rectifier bridge guna diode 4002. So kita punya tak sangat efisien lah sebab kita
Kenapa
mungkin
perlu ada rectifier? Boleh terangkan sikit?
rectifier sebab kita mau hasil AC current keluar.
Okay.
So dia kalau dia jalan sini, dia boleh ulang balik sini.
Alright.
So diode dia, sebab diode dia segitiga kan, dia akan masuk sini, lepas tu masuk balik sini.
Okay.
So lepas tu kita letak sebab dia tak efisien sangat.
Tunggu kapasitor charge up.
Kapasitor dia mau charge up, lepas tu dia akan tunjuk.
Okay. So sana power bank. Okay, power bank. And then dia charge up dekat sini. So ada measure ke berapa
Voltage output.
voltage output, and then you need to calculate lah. Cuba untuk calculate
Sebab
berapa
kita
medan
guna,
yang dihasilkan.
okay, sebab kita guna ini 7805 kan, dia akan produce maintain 5 volt saja.
5 volt. Okay. Kalau dari sini
Dari sini
boleh measure tak? Boleh calculate, bukan measure,
itu
calculate. Dia punya output.
lah. Kita pernah guna itu multimeter.
Okay.
Lepas tu sebab power bank kita hanya produce 5 volt, 5 point lebih volt saja.
Okay.
So dia transfer sini, dia pun 5 volt lebih saja. Dia sama punya. Tapi dia masuk ke voltage regulation kan. Voltage regulation dia akan produce 5 volt saja.
Okay. Boleh tak nanti saya nak you cari mechanism macam mana dia transfer, dia wirelessly transfer the power between this and this.
Dia guna satu rule panggil induction.
Okay.
So dia, ini kita punya tajuk kita panggil electromagnetic induction.
Okay.
So kalau kita hampir sini, so dia akan hasil itu magnetic flux.
Okay.
Lepas tu,
So meaning that sini masuk voltage berapa, sini akan ada current dia kan, berapa. So yang ditransfer ke sini berapa? Macam mana
Sama.
sini? Sama.
current
Macam mana you nak proof kata arus yang dihasilkan di sini adalah sama?
sebab kita punya turn sama. Turn sama, lepas tu dia macam transformer lah. Kalau you turn sama, so 1 ratio 1 So kalau CD produce 5 volt, dia hasil output pun 5 volt.
Ada try measure?
Ada, kita guna multimeter, pernah try dari output sini.
That's all for the presentation of our wireless charging project. Thank you.